Hello friends, so let's talk about the multiple comparisons in one-way ANOVA. Recall that ABC uses nylon fiber from 5 different suppliers to manufacture automobile safety belts. In a previous lesson, we used the statistic and the p-value to test the hypothesis about the varying strengths of the 5 different suppliers' nylon. Because the p-value was less than 0.05, so we rejected the null hypothesis, concluding that the fiber strength for at least one supplier is different from the others. To improve the quality of the belts, however, ABC needs to identify the groups that are significantly different from the others. In this case, we want to know which suppliers produce the strongest fiber. We can use multiple comparisons to identify the groups that are significantly different from the others. Multiple comparisons adjust on fast, so we make fewer incorrect decisions about which groups are different. We will use a method called Tukey's test, which checks for differences in pairs of group means. Each interviewer comparison is like a two-sample test, in which the null hypothesis is that the group means are the same. The alternative hypothesis is that they are different. As we perform more tests, it becomes more likely that we will find a significant difference by chance. To account for this, we use a small alpha for each interviewer test. For each comparison, we will examine the confidence interval to determine whether there is a significant difference between the nylon suppliers. Each confidence interval provides a range of likely values for the difference between the two population means. If the confidence interval does not contain the value 0, then we reject the null hypothesis and conclude that the two groups are different. If the confidence interval contains the value 0, then we fail to reject the null hypothesis and cannot conclude that the two groups are different. The confidence level for each interviewer is adjusted using the Tukey's procedure to keep the overall. Because the corresponding confidence intervals do not contain 0, we would reject the null hypothesis and conclude that the strengths are different for the following pairs: supplier 3 and 1, 5, 1, 4, 2, 4, 3, and 5, 4. You can use the interviewer value plot to determine which suppliers have the strongest fibers. So which two suppliers' nylon samples have the higher mean strength measurements than the others? You can see here that supplier 1 and supplier 4 stand out on the interviewer value plot as having higher mean strength measurements. Supplier 1 and 4 have the stronger mean measurement than the other suppliers, but can we differentiate between them to find the absolute strongest? Return to the Turkish test results that compare suppliers 1 and 4. We can find and can we find any statistical differences between the two? So here's the result. The results show that the means for supplier 1 and 4 are not significantly different from one another. Ultimately, we can use multiple comparisons like Tukey's method to make strategic decisions. For example, The ABC quality engineer could improve product quality by recommending using fiber only from the two suppliers with the strongest nylon. She could also save the company money by comparing the cost of supplier 1 and 4 and recommending using the supplier with the best prices. The quality engineer might also want to gather more data to study suppliers 1 and 4 to see if um, we can discern any differences between the two. So let's review. We learned how to use multiple comparisons to determine specifically which groups differ from one another. Confidence intervals containing zero mean we should fail to reject the null hypothesis that the two group means are the same. Intervals that do not contain zero indicate we should reject that hypothesis. Thank you for your listening. In the next lesson, we'll talk about the assumption and residual plots.